right, check your answers with mine. For number 1, the final answer was 24y to the 3rd over x to the 8th. Get that. Really? That is all. I mean, that makes sense. How you got that? I have the same answer.
So I'm guessing this is like the y on the top.
Yeah. Say, the base right now is 1 over y, so if you take that and flip it, it would just be y. I mean, that's you gotta flip it. Number 2, the final answer was 324 x to the 10th. Questions on that one? Number 3, whoever the student was did not simplify this correctly. If you did simplify it, you would get 25 x to the 8th over y squared.
So what was the question like on the test? Can we just put no and you have to like show the reason why?
Wait, so they're gonna be word problems on this test?
If we've done any word problems.
With like, will it?
Oh, on SOL A2, I'm going to run through the answers. Let me know if you have questions. And then for 2B and 2C, I'm going to show you how you would do this in Desmos, as we haven't talked about these things yet. All right, number 1, 16 over x to the 10th. Number 2, 5y to the 15th over x to the 7th. Number 3, x to the 5th, y over y to the 8th. Number 4, 16, y to the 7th. Number 5 was 25x to the 4th. Number 6, y to the 3rd over 6x to the 4th. And number 7, 8 to the 11th. Questions on any of those? Number 8 was D, 32x to the 10th. Questions on that one? For 2B, so this is like a cheat method that, for the most part, this works almost every time. If you take, and I know we haven't talked about this entirely, but if we take this first term and this first term and divide them, and take the last term and this last term and divide them. For most of these problems, the answer you get when you do that should be the answer for the problem. Like I said, this is a cheat method, and because you don't know how to actually solve this, that's all I'm going to say for this. So we're dividing like bases, so we would be subtracting our exponents, so this would just be x, and then we would just divide here, so negative 5. Yes, do
What do
it.
you do now?
For now. Later, we'll actually show how we would actually do this, but for now, we could just do it like this. So same thing here, 2x squared divided by x would be 2x. Negative 8 divided by negative 4 would be positive 2. Disregard this part for right now. Squared divided by 2x would be 3x. 15 divided by negative 3 would be negative 5. I just I'm gonna do this again. The other thing you should do is put this into decimals. So can you say so let's say I put in 12 into decimal 7x squared plus 12x plus 5. If you were to put this in decimals, it's going to give you a line because you're taking this quadratic function, which again you don't really know much about, something that's squared and we're dividing it by something that's linear. You're going to end up with something that's linear with a line. So when you end up with that line, you could find your slope and minus of that line and look at it like that. So our y-intercept is 5, our slope is negative 7 could be negative, positive 7 x plus 5. So that's another way you could look at it, or you could still just do the dividing thing, 7x squared divided by x. Either way, you can look at that either way.
Or I have a question. So why would not include the
Because the way we actually use this is factor and we have Number 13 will be x minus 3. 14, 3x plus 1. 15 is a little different because you don't have two things. You would have to take this 4n and divide it under both. Again, this is something we haven't talked about yet, but we know next minute. But if we're dividing both of these things by 4n, we can do this because we have to talk about dividing by bases. The 16n squared over 4n would be 4n. 4n over 4n would be 1. 4n plus 1 would be that final answer. This would be another one we could put in decimals, but you have to change the n to x, and you get the same thing. For things like 16, you could put each of these in, and see which one crosses or matches. Yeah. This off to me, so I'm gonna do them. Yeah, the actual problem first, and then we'll do the others. Minus the actual one. And then all of the different answer choices, so x minus 4 is
Plus 3x minus 4. Plus 3x. Negative 3x plus 4. Negative 4 minus 2.
So you see the blue line got overlapped by the black line. They match the other answers. And then the next one, again, these are things that we're going to talk about in the next unit, but here are the answers. All of the factors for 8x squared minus 18 are these three. 2x minus 3, 2x minus 3. Say that again.
We're going to
With this, not all of these you could check the textbook, but some of these you could. So like 8x squared minus 18, if I put that in, and put in some of my answer choices. And let's say I put in, I'll just put in the, yeah, I'll do 2x minus 3 plus 3, and then x plus 2, and we'll see what I do with that. What was that one? So what's different about these is that these two both this the original at the x-axis. That's how you know those are correct. This one does not. So if it goes through these points, then it is a factor solution, whatever, but it has a better way to put it. We're not going to go through why these answers, some of these answers are the way they are. I'm just going to tell you what they are. We'll go through that later. So A is x minus 1, x minus 3. So when we do this unit, we'll go back to this, and then hopefully it'll make sense. B, this one you should be able to do because we talked about x and y intercepts before. So if you put in my order here, this will be 1, 0, 3, 0, and then 0, 3. This one you should also be able to do. We talked about the main range. This would keep going up and left, up and right, so all our numbers. Range would start at -1 and keep going up, so from -1 to infinity. Again, for this one, you could put all of these answers in. See where does it cross your x-axis exactly. 2x plus 5 would be your answer. For 20, x plus 6 would be your answer. And then for 21, D is your answer. The next ones that you are going to do is A3. So that one you should be able to do completely because that's all the radical stuff that we've already touched on. do all of A3, and that will be due end of next week, the last time I see you next week. It'll either be Wednesday or Thursday, whatever day it is for you guys.
Wait, so it'll be Wednesday?
Yes. Everyone should have these notes on their desk. Alright, so we talked about all of our exponent rules. Now we're going to talk a little bit about something else that's related on rational exponents. Fractions.
What?
So,
Fractions was the first one.
when we do this, if we have something where we have a to the 1n, whatever n, this would be the nth root of a. So whatever that number is going to be whatever the root is. So if it was 2, it'd be a square root. If it was 3, it'd be a cube root. 4, fourth root, and so on and so forth. And then your a would be on the side. If you have a fraction where you have a numerator that's not 1, n would still be your whatever number, but then you would raise a to the nth power. So with the letters, that doesn't really make a whole lot of sense, but with these examples, hopefully it starts to. So for number 1, we have x to the 1/4. How would we write that in radical form? The 4th root of x.
And wait until we get
Look at the next page now.
Alright, so you're at the bottom, the multiplication.
Some of them will get a little. Alright, 15n to the 1/2. How would we write that? The root of 15n. Now,
What does the 1/2 do?
so really there's a 2 on the outside, but you usually don't write that. You can write it if you want to. It's a square root.
So you don't have to simplify anymore.
In this case, we don't because 15 can't be simplified and n can't be simplified. But if we got something that could be simplified, we would need to simplify it.
That sounds like a plan. So basically, what we did last minute.
It's a square root. 24 to the 1/3. How would we write that? Root of 24. Now, we can break this down.
Yeah.
We can use The highest perfect cube that goes into 24 is 8. So if you can break this down, you also have to do that. The cube root of 8 is what?
2.
Five.
Anything that is just numbers, you can check in your calculator and it should work out to be the same. Thank you.
The answer would be 2 times this what?
It's kind of weird to think that 24 to the 1/3 became 2 times the cube root of 3, but that's what happened. 7 to the 2/3. The cube root was 7 squared, and then we became 7 squared to 49. 49 we could not simplify more because the only factors of 49 are 1 and 7, 7, and 49. So there's no groups of 3. That would stay the same. A to the 7 halves. How would we write that? Now if we have the square root of k to the 7, we can simplify that more because 2 goes into 7 how many times? 3. With how many left over? For number 6, how would we write 3 to the 5/4?
Okay. So fourth root. 3 to the head.
Wait, Miss Storm, what's the answer for 5?
K to the 3rd times 6 square root of k. Now, for number 6, we could figure out what 3 to the 5th is, and then in order to really break it down, we would have to know what perfect fourth or the fourth is. That's confusing with itself. So besides not doing that, 4 goes into 5 how many times? 1. So that means 1, 3 would stay. So instead of doing 3 to the 5th, we can just do it like that, and that makes it simpler. Say that again. So if I put this, I'm going to type this in the calculator. If I put this and this in the calculator, it should be the same thing. 3 to the 5/4. And 3 times 4 root. So you can check those numbers and you still get it. Left over. 3 that comes out and 1 stays. AB to the 3/4. However, because we now know our exponent rules, we know that we could take that exponent and multiply it to the exponents of a and b. So this would be the 4th root of a to the 3rd. like show that you multiplied 1 and 3. No, you could jump right to this.
Can I do some more?
No, because 3 doesn't go with the 4. If it was 5, then yes, but in this case, no. For number 8, how would we write that?
Copy you? That makes no sense. Excuse you?
Okay. Just like number 7, we can raise 2 to both of the exponent powers. I don't have space for this. I'm doing this over here. So this would be negative 6 squared. And x squared. So yes, 36. For 36 is the highest perfect cube, and that wouldn't go into cube 36. 6 squared.
Oh, not my. Wait.
Wouldn't it be 9 and 4?
9 and 4 work, but then you get 3 and 3 and 2 and 2. There's a lot of 3.
No, but
So it
9 can
wouldn't-
be divided by 3. So it can be like come out or something.
If it was a square root, then yes. But because it's a cube root, no. For number 9, how would you write this? Seven go inside the square root. Not outside of these parentheses, so it's not going to go underneath. Can we do anything else to this? Yes. What?
Like the same as the whole button.
Say it again. That would only be for the exponent. That's 12. You can break down 12. So we multiply 7 and 2 to get 14, and 3 and W underneath the square root. So again, it's weird to think 7 times 12W to the 1/2 would mean 14 times the square root of 3W. That's what happened. Going from exponent form to radical form, for me, I feel like is harder. Not that it's hard, because once you get the hang of it, it's not that bad. Than going the opposite way. So if we are now given radical form and we have to write it in exponent form, how would we write the cube root of 16? And there's nothing we need to do with that. We don't need to convert it back or solve it or anything like that. How would we write 11?
X, Y,
It's like.
Now, if I just write it like this, are both things being raised to 1/2? Number 12. Are both of these things being raised to 1/4? Remember your parentheses. Number 13, how would we write that? So if it's being raised to an exponent, that exponent just becomes your number in your numerator.
Does it not work if you do 11? Square root of 2 including anything else?
Say that again.
Like if you put 11 in the 2 parentheses,
11, and then, so it's not for the thing like this. And then 2 pi 1/3. This and this is the same, but this is not simplified. You have to multiply your exponents. Now 15, the exponent is on the outside, but it still does the same thing as if it were in the inside.
So if you lay out in parentheses,
How would you write that? 17 would be similar. Is everything would be in parentheses. And then 18, how would you write that?
parentheses.
So now that you know how to write one and the other, and vice versa, now we're going to actually use both to help us simplify. So for this, the easiest way to do this for a lot of these problems is not all of these problems. Some are easier in radical form than others. Rewrite the radicals in exponent form or exponential form. Use your exponent rules, because we know all of those. And then at the end, rewrite it as radical form and see if we can simplify it. So for 19, we are multiplying by bases. What are we doing with the exponents? Adding. This will give us x to the 3. So now we can write this in radical form. What would that be? Adding the two fractions. So we're combining a bunch of things. Radical stuff, exponent stuff, and this stuff all together. Can this be simplified more? 3 goes into 5 how many times? Twice. Once, sorry. With how much left over? I don't know if that would be easier.
I do that.
In that case, yes, but not all cases are going to be like that. So I'd say be careful. Right, number 20. We are again multiplying like bases. We're adding our exponents, but these exponents are not the same denominator. Yeah, so you would have to make them the same. You can either do that algebraically or do it in your calculator, either or. what would your exponent be?
7.
What would that be in radical form? 4. You simplify that more. Yes. 4 goes into 7 how many times? Once. Once. With how many left over? For 21, we are now dividing like bases. So what are we doing with the exponents? Subtracting.
Oh, okay.
What would our fraction be?
Yeah.
What would that be in radical form? Can this be simplified?
No.
For 22, we have an exponent being raised to an exponent. What are we doing with the exponents? Multiplying. So they're not level, but you're multiplying across. So 1 times 5, and 3 times 2. And how would we write that in radical form? 5 over 6. Can we simplify this? No. Let's jump to 24. For 24, we're doing the same thing, but now we have multiple things inside the parentheses. So we're still multiplying our exponents, but 8 also has to get the 2 to the third. X squared times to the 2 to the third. 4 to the third. The 2 would be over 1. So writing these both in radical form, what would 8 to the 2 thirds be? And x to the 4 thirds. So you can combine them and then simplify, or simplify them and combine, doesn't matter. I'm going to combine first. And 8 squared would be 64. Now, we need to see, can we simplify? Is 64 a perfect cube? Yes. The cube root of 64 is what? 4. 3 goes into 4 how many times? Left over. Squared. So again, it's weird to think that 8x squared to the 2 thirds is 4x times the cube root of x. But that's what happens. Before we continue, how do we feel about this? It's okay if you're okay or not good with this. It does take practice.
I'm like,
in between those.
Okay.
Do we have any questions on any of this so far? We are, no. What do you guys will be doing for three? Where did the 4 come from? 4 came from this 64. 3 goes into 4 once. This is that X got brought out. This is a negative. If we have 100 raised to the negative 1/2, our negative exponent rule still comes into play. This would be 1 over 100 to the positive 1/2. Now we can write this in radical form. What would this become? 100 to the 1/2 would become what? Square root of 100. 1 over the square root of 100. What is the square root of 100? We're not doing 26, but 26 also has a negative. 7. 27 also has a negative. So taking that negative into account, how would we rewrite this first? Yes, I'm going to write it before we take the partial form, but if 216 squared, that would become 1 over the cube root of negative 216. The 1 over the cube root of negative 216. What is the cube root of 216? So you could also write this with the negative out in front, or you don't have to write all 3 of them, just pick one. Yeah, that would be your final answer, negative 1/6. Other questions on that one? 428. Can we divide these two? Can we divide 107? Try it.
Yeah.
That can help us a little bit. So how would we write this to change our negative exponent? How would we take this and put it in radical form? One over the fourth root of 16. Now, we don't know the perfect fourths, but we do know that 2 to the 4th is 16. So we can change that. Because these are, and we will do this for the last two also. I'm going to put this in the calculator just so you see that this works. Because it's clear that 112 over 7 to the negative 1/4 became 1/2. When you look at it. But it does. So a lot of the time you'll like work this out and it'll really be like, what did I even do? How did I get this? But it works. Alright, we're just gonna do a few more, then you'll have time to practice them.
I would use this as a example.
29, 31, 32, 34. Right, 429. For this, you could leave it in radical form and simplify it like that, or you could do it back to exponent form. At this point, it's really which one you feel more comfortable with. If you were putting it back in exponent form, b to the cube root of b would be what? Third root of b would be what? Then you're multiplying like bases, so you're adding your exponents. And that would give you you get common denominators. Not 1/6, but it is over 6. 5, 5, 6. In radical form, what would that be? Can we simplify that?
That's because
For number 31, let's rewrite these as exponent forms. So the one in the numerator would just be 4 to the first. How would we rewrite the cube root of 4? We are dividing like bases. What are we doing with the exponents? Adding. Or would we write that in exponent form? And then 4 squared gives us 6. This we can break down more. 8, yes. Cube root of 8 would So if you have numbers, I would definitely check them because 4 over the cube root of 4, 2 times the cube root of 2 is mind blowing. $32. I'm going to show you both ways of this. If we put this in radical form, because we have the same index, they're both square roots. This would be the same thing as the square root of 7 to the third over 7. Then we can take our exponent rules and subtract. And this would be 9, 7. If you did it in radical form, you're going to get the same thing, it's just going to look different. Let's do this bigger. This would be 7 to the 3 over 2 over 7 to the 1/2. So 7 to the 3 over 2 minus 1/2. 7 to the 2 over 2 or 7 to the first. So if the index is the same, then you can go with that process, keep it in radical form, and so on and so forth. If it's not, then changing it back would be ideal. For this last one, I'm going to change this to exponent form first. We have 25m squared to the 1/4. We would multiply our exponents. We have 25 to the 1/4 and m to the 2 over 4. Now, you can simplify it 2 over 4. I'm going to do something with the 25. Because what do we know is also 25? What's 25? Right. 5 squared. So if I know that 25 is the same thing as 5 squared, I can change this. And then multiply those exponents. And then simplify those fractions.
So the fraction rate.
Here. Now we have the same fraction for both. So you can write them separately or write them together. Write them separately and then together. So this will be the square root of 5. And the square root of m would be the square root of 5. There are 4 problems on this that we did not do that I want you to try. And then if you finish those 4 before we go over them, you do have 2 academies on this and 1 Delta Math that would be due Monday. So numbers 23, 26, 30, and 33. Do those 4. And then we'll probably go over this towards the last 15 or so minutes of class. And then you can work on Delta Math and contact. If you have any questions on any of that, you can bring it up to my desk. Yes, give me a second. So for 23, final answer was 2 times the 4th root of 2. For 23, you also could have changed this. So like after you got this part, 32 is the same thing as 2 to the 3rd. And then you could have multiplied your exponents and changed that to radical form. And then simplified it like that. But whichever way works better for you, do that. Questions on 23? The final answer was 2 times the cube root of 2. So the same thing we did here, you could do for 16, because 16 is 2 to the 4th. But whichever works better for you. Questions on 26? Okay. For 30, final answer was R2, I'm sorry, no, just R times the 4th root of R. And 33, really for this one, you could have simplified this into this or looked at this the radical form for looking in the twice, only 2 left over. So x squared times the square root of x. Questions on 30 or 33? You can put your calculators up.